Welcome to the tutorial on numerical on analysis of sequential circuit. So here we need to follow some steps in order to deduce and obtain the state diagram. So first would be to determine the system variables, that is the number of inputs, outputs and state variables that are involved. We need to assign names to these variables if they are not clear from the logic diagram or the circuit diagram that they have given. The third step would be to determine the flip-flop type and write its characteristic equation. This is a very important step because you will require to know the characteristic equation of each and every flip-flop. So this will not be given to you, so you are required to be aware of the characteristic equation. The fourth step would be to write the excitation equations by looking at the logic diagram or the circuit diagram. The fifth step would be to write the next state equations for each state variable using the flip-flop characteristic equations and circuit excitation equations, or construct the excitation table from the excitation equations. The sixth step would be to write the output variable equation and determine whether the circuit is mealy or Moore machine. Seventh step would be to construct the transition table from the present state and the excitation equations. And eighth step is to assign the symbols to the states and construct a state table, and finally the state diagram. So these are the steps to be followed when you are trying to analyze a sequential circuit. Analysis of sequential circuit basically means from the sequential circuit which has the flip-flops, you are going to reduce it to a state diagram representation. So let us look into the first numerical that is involved. So I have named this in a continuous manner because these numericals are in similar path towards the state machine notation numericals, whereas the state machine notation numericals were of the reverse order compared to the analysis of the sequential circuit. So this will be considered as numerical 3 in my case. So do watch the previous tutorial on state machine notation numericals to understand the flow. So the numerical says analyze the following sequential circuit that is shown, and you need to obtain the flip-flop input and the output equations, transition table, state table, and draw the state diagram. One important note to be noted here is that not always the question will be asked in much detail like the way they have given here, wherein they have deduced the question into 5 different steps. Sometimes they will directly ask you to analyze the sequential circuit. That means you yourselves have to deduce it to obtain the state diagram. So to begin with, we will have to look at the circuit that has been given to us and identify the system variables. System variables means we need to identify the input. The input is X, output is Y, state variable is Q. We have only one single flip-flop, so only one state variable Q is present. So the second step is to identify which type of flip-flop. So clearly it is mentioned in the question. So it's a T flip-flop, and we should be knowing the characteristic equation of the T flip-flop. So that is QT plus 1 is equal to T XORed with Q. And the excitation equation for this will be obtained by looking at the flip-flop, the sequential circuit. Okay, so you can see that this is XQ, this is X bar, Q bar, and then you have an OR operation. So if you observe the excitation equation, T will be equal to XQ plus X bar Q bar, which is obtained from the sequential circuit that is given. And the next state equation that you have here is Q plus will be Qt plus 1 is equal to T XORed with Q. substitute, and this is what you get as the next state equation on simplification. The output variable, if you look at this, is y, and that is equal to xq. So the next step would be to obtain the transition table. So for the transition table, we have the present state, that is q, because it is just one state, right? So present state q, and the next state represented as q plus. Now the input x can either be 0 or 1, and the output is single, so that is why I have represented the output here. So depending upon what is the present state and the next state, I need to fill in the contents of this particular next state. So present state is 0 XORed with this part. So you have 0 XORed with 0, that is equal to 1. 1 XORed with 0 is equal to 1. So that is why you have obtained this to be equal to logic 1. The output is x into q. So 0 into 0 is 0. Let me consider the next one, that is x is equal to 1. So you have 1 XORed with 1, that is equal to 1. XORed with 1 is equal to 0. So if you look at this, you get 0 here, and the output is 1 into 1 is equal to 1. So this is how you obtain the transition table. That is, the next state contents are obtained by simplifying the present state and the input x in this particular expression. Once a transition table is done, you will be obtaining the state table. For the state table, you will require assignments. So you will assign two values, that is because your transition table had two values, 0 and 1. So I am going to name the two values 0 and 1 as A and B. So the state table will now have the present state A and B, and I am going to replace this with A and B correspondingly. So this is B0, A0, A1. Finally, I can draw the state diagram by looking at this particular state table. A to A with input x, but output is 0. So when it is 0, you have to complement this. There are two ways of writing the state diagram. I can represent in terms of x bar, y bar, or I can represent it in terms of ones and zeros in this case. So similar type of a state diagram I had explained when we saw the numerical for state machine notations. So it's possible to represent either in this form, or you can represent in terms of ones and zeros. So this is one of the simplest problem that can be solved. So next numerical is given here. So here they have given that you need to provide the output function, excitation table, and the state transition diagram by analyzing the sequential circuit shown below. So the process is going to remain as it is, but this particular circuit looks much more complex in comparison to the previous one. So here they have specified you the variables, and it's looking quite complex to identify the input variables and the output variables. So let us see how to solve this. So if you see here, inputs are A and B, and the output is X. So inputs is A comma B and output is X, and because you have two flip-flops, we are going to consider the state variables as QA and QB. Clearly this is an SR flip-flop, so we need to know the characteristic equation of the SR flip-flop. So QT plus 1 is equal to S plus R bar Q, and excitation equations have to be found out. To find out the excitation equations, look at the circuit, that is a sequential circuit. So here the excitation equation SA will be equal to A bar. Excitation equation RA will be equal to A bar A. Excitation equation SB will be equal to A into B bar, and excitation equation RB will be equal to A into B. Once the excitation equations are known from the circuit, you need to substitute and find out the next state equations. So you have QT plus 1, which is going to be now represented as QA plus 1 and QB plus 1. Instead of representing in terms of T plus 1, here it has been represented as plus, just a simple plus. Because there are two flip-flops, so separately we are going to have the two next state equations. SA plus RA bar Q will be equal to, what is SA? Substitute. What is RA? Substitute. What is SB? Substitute. What is RB? Substitute. And this is what you get. Output variable X will be equal to B into A. So X is equal to RA into B, that is equal to A into B. So the next step would be to write the transition table. Now, like the similar manner, when we write the transition table, we have to look into these expressions for the next state equations, and that is A bar plus A bar QA and QB plus to be equal to AB bar plus AB bar QB. Based on these next state equations, the contents of QA, QB are going to be filled. Because we have the present state of the form, that is 2 QA and QB, so we will be having 4 different combinations of QA and QB, 0 0 0 1 1 0 1 1. So we need to fill the contents based upon these. So how we are going to do that is, QA is 0, A and B is equal to 0 0. Okay, what is it going to be? QA plus. So you need to substitute for A and B and find out what is the value of QA plus. In this particular expression, B is missing, so you can forget B. Just A bar is very much essential. So 0 is QA. Okay, 0. A is equal to 0. So this is going to be the complement of this. That is 1 plus 0 is going to be 1. Output variable X is equal to 0 into 0, that is equal to 0. So this is how you fill in the contents, and you have to be very careful while filling all the contents, because these contents will be filled based upon the based upon the next state equations that have been specified here. So I'm not going to explain each of them in detail, but try to relate individually. Remember, when you're watching QA, you have to watch A and B and X and fill in the content only for QA plus. That is the next state QA. Okay. When you want to fill QB, you have to watch QB, next state A and B, and then fill in for QB. So same thing follows for all of them. Finally, you have the state assignment that needs to be done. Because the state values are two variables, so the assigned state will be of 4 A, B, C, D. And now it is easy for you to simplify and obtain the state table, because you know how the transition is going to occur. If 0, 0 is A, then 1, 0 is C. So A to C with output 0. Then 0, 0 to 1, 0. So A to C with an output 0. 0, 1 is B. So A to B with an output 0. This is A to A with an output 1. So this way state table can easily be obtained. From the state table you can obtain the state diagram. Now again, as I repeated earlier, you can specify the Mealy diagram. This is the Mealy state diagram, either by using zeros and ones, or you can specify in terms of the variables. So here I have preferred to denote in terms of variables, that is wherein your transition is occurring. So based on this particular thing, you need to draw the state diagram. How to draw is that, for example, let me say you're making a transition from A to A. Output is equal to 1. So that has to be written as it is, X. If it's complemented, you have to denote it as X bar. So A to A. So here you have the next state as 1, 1, which is equivalent to writing AB. So A to A transition occurs when the inputs are AB bar, output is X. Another example, let me consider A to C. Okay, A to C, there are two cases that occurs. When you have the transition with inputs A bar, B bar and X bar, okay, or you have A bar, B and X bar. So that is why this transition is also represented as an OR, because there are two cases in which you jump from A to C. So this way it is easy for you to deduce to the state diagram. Moving on to the next numerical, they have specified that you need to analyze the sequential circuit shown having two D flip-flops with positive edge clock inputs, a single input variable X and a single output variable Z. So in this case, X is the single input variable, Z is the output variable, two flip-flops and the flip-flop is D. So here input is X, output is Z, state variables are F2 and F1 because they have been specified, so we need not separately denote them as QA and QB. They themselves have specified, so I have considered the same. So that completes our system variables. Flip-flop type is D. Characteristic equation has to be known to you, so Q plus is equal to D. It's always very easy when you obtain a D flip-flop because you know that characteristic equation will be the same as that of data. So excitation equations you need to look into. D2 is equal to F1, F2 bar and X. Similarly, D1 is equal to X1 bar plus F2 bar into F1. So output variable, now before that we have the next state equations. For next state equations we are going to denote it as F2 plus and F1 plus. Okay, that is because we have considered state variables as F2 and F1. So since here the excitation equations and next state equations are going to be exactly the same because the characteristic equation was in this particular form. So output variable equation has to be obtained looking at Z is equal to F2 into X. So this is how you get. Then you need to obtain the transition table. For the transition table you need to look into F2 and F2 of the present state and the next state. So here it is very simple. That is because you are going to just look into what is the present state and what is the next state. So just substitute the values here and that is what you get. So you have F2 to be equal to F2 plus, that is, if I am to denote this next state as F2 plus will be equal to, look at the expression of F2 plus, F2 bar, F1 into X. So F2 bar is 1, F1 is 0, plus X is 0. So that's why you get it as 0 here. And the variable Z is equal to F2 into X, and that is why you get it as 0 here. So in a similar manner, you are going to obtain all the remaining contents of the next state table. From there, you are going to assign the states. Because there were 2 D flip-flops, we are going to have 4 states A, B, C, D, and from that you can directly obtain the state table wherein you have assigned A, B, C, D, and you can obtain the state diagram. Again, I repeat, the state diagram in this case as well can be represented either in the form of the variables X and Z or in the form of zeros and ones. Either way, it is correct. So these are some of the easier or some of the more complex problems that we have seen, such as these, wherein it was difficult for us to identify which was the input and which was the output. But remember that these kind of problems are very much frequent in your semester exams that will be asked. That is analysis of sequential circuits.